If Earth's 4.6 billion year history were squeezed into 24 hours, then from midnight to this very moment, what great events would we see appear? At midnight, Earth formed. Back then, Earth was not yet the blue planet we know. It looked more like a cooling ball of fire. Oceans of magma covered the whole globe. Meteorites rained down without stopping. The young Earth looked like a hell drifting through space. At 028, a collision that would rewrite Earth's fate struck. A Mars-sized young planet slammed into the early Earth. Its name was Theia. After the Great Collision, huge amounts of mantle rock flew into space. Gravity then pulled it back together, forming the moon. The moon was more than a night skylight. It brought powerful tides and made Earth's spin axis more stable. Ocean rhythms and climate shifts for billions of years after, and even the evolution of life, all trace deep ties back to this impact. At 102, the ancient oceans began to form. The young Earth slowly cooled. Water vapor condensed. Rain fell. Earth shifted from a magma world into a planet with oceans. But this ocean was dark and scorching hot, a primordial sea full of chemical reactions. At 20513, the common ancestor of all life had appeared. It is called Luca, from bacteria and archaea to plants, animals, fungi, and humans, all trace back to this ancient source. At 41026, Earth's rocks preserved traces of early life. Life then was still incredibly tiny, maybe just single-celled microbes. But from this moment on, Earth was no longer just an ordinary rocky planet. It now held a brand new variable: life. At 954, cyanobacteria started to flourish. These tiny lifeforms learned to use sunlight, turning carbon dioxide and water into organic matter, releasing oxygen. This oxygen reacted with iron and other matter in the sea, leaving huge red-banded iron formations across the Earth. At 1128, the Great Oxidation Event arrived. Oxygen rose sharply in the oceans and the air. For many anaerobic microbes back then, oxygen was a deadly poison. Countless anaerobic lifeforms declined or even died off. At 1436, eukaryotes appeared. Their cells developed a nucleus inside, and energy factories like mitochondria appeared, giving them far greater control over energy. The future plants, animals, and fungi, including us, are all eukaryotes. At 2014, the Snowball Earth event began. The whole planet was sealed in white ice. Life held on near hydrothermal vents beneath the ice. Luckily, the white did not last forever. When Earth thawed again, new chances came with it. At 2041, the Ediacaran period began. Earth had just recovered from the deep freeze. Ocean conditions changed in a big way. Complex life began stepping to the front. At 2052, early animals grew active. The rise of sponges marked life entering an age of real body structure. Cells no longer just survived alone. They began to divide labor and cooperate. They joined into bodies and formed tissues, laying the groundwork for future complex animals. At 21 Tumid, the Ediacaran biota flourished. Many soft, flat creatures filled the oceans. Strange life shaped like leaves or discs. Some looked like plants. Some were closer to animals. Many are still hard to classify today. For the first time, life took on clear shapes on Earth. At 2110, the Cambrian explosion began. In a very short stretch of geologic time, many animal groups suddenly appeared in the fossil record. Shelled animals